Hello everyone, welcome to this video. In this video, we are going to talk about a very dreaded concept among the candidates. Like, lot of people really scare about it. I really don't know why. The topic is recursion. And let me tell you, like, lot of people, when they start learning Python, a point comes when they actually stop studying because or they feel too demotivated or things get too overwhelming, and recursion is such a topic. But I'm not here to scare you. In my opinion, recursion is one of the most easiest topic in Python. The problem is that people complicate it too much, and that is why like even for candidate it gets very difficult to understand. But recursion can be taught in like two simple steps, so don't get scared. I'm just telling you that you might have heard the word recursion here and there, right? And you must be thinking, okay, what is this recursion technique, right? So that's why I'm just telling you this topic is there. It is there for long. People scare it, but to be honest, this is very easy. This is like just couple of things you need to remember, and everything will be for very easy for you. So in this video, I'm going to discuss the recursion. What is recursion exactly? We will discuss three examples one by one, and in the end I will share an assignment with you which you have to solve and submit by the deadline. So without wasting time, let us start with the recursion. So let us understand the theoretical definition of recursion first of all. The theoretical definition of recursion says that recursion is a programming technique where a function calls itself in order to solve a problem. Now, as soon as I said this, you must be thinking, what does it mean by function calling itself in, like, what does it even mean, right? Because when we write a function, till we complete it, how can we call a function before even it's completed, right? So technically this is what recursion it is. Programming languages allow that, but we will discuss that what does this exactly mean. We'll understand through an example, not one example, we'll see multiple examples, and which it will help you understand what is recursion. So recursive functions are helpful in situations where a problem can be broken down into a smaller and identical sub problem. So this is very important part. When to apply recursion is when a problem can be broken down into smaller and identical sub problems. Okay, but how to identify if a problem can be broken into smaller and similar problems? So let us come back to our board. This is these are like Russian nesting dolls you would have seen some in some movies or somewhere. So what you see, like, there is a big doll, then there is a small doll, and as you go from left to right, see the sizes of doll are decreasing. Okay, they are decreasing, and they're decreasing. So what you can do, you can put one doll inside other, inside other, and something like that, and you can technically put all the dolls inside one bigger doll, right? So what will be happening is that you can actually create one big doll, right? Inside that there will be one smaller doll, then inside that there will be one smaller doll, then smaller doll, and so on. You will keep on going. So this is what recursion is, that whenever there is a problem which can be broken down into smaller, simpler problems and identical, you have to apply recursion. So let us look at with one of the very famous example, the factorial, right? We'll try to understand recursion through factorial. So what does factorial mean? Factorial is basically, let's say factorial of a number n is multiplying all the numbers starting from n till we reach 1. So what does it mean? For example, let us say you have to calculate factorial of 7. So how will you calculate the factorial of 7? It will be 7 into 6 into 5 into 4 into 3 into 2 into 1, right? This is the factorial of 7. Now let us talk about factorial of 6. So what is the factorial of 6 here? The factorial of 6 will be, if you know, take that number, okay, and keep on multiplying till you reach the end number. 5, 4, 3 into 2 into 1. Similarly, 5 factorial will be, it will be 5 into 4 into 3 into 2 into 1. And so on. Like, for example, 2 factorial will be equal to 2 into 1, and 1 factorial will be equal to 1. Okay, so what do we see here? As we are progressing from here to here, do we see a kind of pattern? The pattern is that factorial of any number n can be written as, so for example, factorial of any number n can be written as it is. So let me just clear this board first of all. So let me first clear this. So factorial of any number n is technically, it is equal to n into n minus 1 into n minus 2 till you reach 1, right? For example, 3 into 2 into 1. This is the factorial of any number. Now let us try to identify a pattern that I was saying. If I tell you that, for example, the 7 factorial that we calculated for it, the 7 factorial was 7 into 6 into 5 into 4 into 3 into 2 into 1. Now, if I say that in this particular part is 6 factorial, because what is 6 factorial? 6 into 5 into 4 into 2 into 1, right? So technically, how can I write 7 factorial? 7 factorial is equal to 7 into 6 factorial. Okay. Similarly, for example, if 6 factorial is given to you, how can you write it? You can write it as 6 into 5 factorial. Similarly, 5 factorial you can write down as 5 into 4 factorial, and that's how you will keep going on. So if I have to generalize this term, how can I say that? I will say factorial of any term n is equal to n into n minus 1 factorial, right? Okay, so what does it mean? It means that factorial of any number n is equal to that number n into factorial of n minus 1. So if you see this particular function can be created as a product of its own itself of a lower value. For example, a factorial of n can be broken down into a factorial of n minus 1, right? And this is where we derive the concept of recursion, that okay, I see that to calculate any factorial, I just need to calculate that number and then I call a function lower than this. Okay, so how will this start working? So let us understand how will this start working in terms of factorial. Those who already know, you can skip little bit ahead because this might be repetitive for you, but for those recursion is new, you please stick to this. So as we mentioned, factorial of n is equal to n into factorial of n minus 1. Now let us understand this from a new perspective. Now, for example, let us say I have to calculate factorial of 7. Okay, I mentioned that 7 is equal to 7 into 6 factorial, right? Now point is that, let us say I don't know what is 6 factorial. Now can I break even 6 factorial further? Because as per the logic, I can break even 6 factorial, right? So what will I do? This will become 7. So I will now break 6 as 6 into 5 factorial. Okay, so what is happening? 7 into 6 into 5 factorial, right? And it will keep on going. For example, you can keep on going. Suppose you went from 7 into 6 into 5, you will keep on reducing your number, 4 into 3 into 2 into, let's say, 1 factorial. Now suppose you didn't know the value of 1 factorial, or let us say you didn't know the value of 1 factorial. What will you keep on doing? You will keep on reducing. You will say, okay, 1 factorial is technically is equal to 1 into 0 factorial. Okay, then you will say 0 factorial is equal to 0 into 0 minus 1. So minus 1 factorial, right? That's what you will keep on writing. You will say minus 1 factorial is equal to minus 1 into minus 2 factorial. Okay, you will keep on writing this. Agreed? Now, if you see that a point comes, like this situation will go totally out of our hand. So we need to have a base case. base case is that we know that 1 factorial is equal to 1, or we know that 0 factorial is equal to 1, because if we don't stop it, we will keep on multiplying till like 7 into 6 into 5 into 4 into 1 into 0 into -1, and so on we will keep on doing, right? And what will happen that we will never stop. We will start from a number and we will keep going till infinite time. So to stop that particular infinite loop, we have to define a base case that, okay, up to what point are you going to do this activity, what you are doing, that okay, you are calling a function again. There needs to be a base case. So this is called a base case, the value for which you know. Okay, so what you do, you start from a point and you have to iterate from there to the base case to get the result. So basically fn becomes equal to 7 into 6 up to 2, and you will move forward till you reach the base case. So one is base case, which is very important, right? Remember why base case. If base case is not present, you will stuck in an infinite loop, right? You will keep on reducing, you will keep on calling till you, like this thing will never end, right? So that's why you need a base case. Once you have a base case, you can keep on calling one lower function till you reach the base case, and eventually you will sort the result. Okay, so this is how a recursion works in a, I'll say, on a simple case. We'll understand it using coding now. So let us understand this factorial example in terms of coding using recursion. So we will write down, so suppose we'll write down a function def, okay, factorial. We have to calculate a factorial using recursion now. So what will be parameter to my function? It will be n, the number. Okay, now think like this. We need to have a base case first, right? What do we know about factorial? We know that 0 factorial is equal to 1 or 1 factorial is equal to 1. So we will use this. So first of all, the step is writing a base case, because base case, as I mentioned, without base case, you will stuck in an infinite loop. So you have to write down a base case. So what is a base case? You will write down that if n is equal to 0 or n equal to 1, if n is equal to 0 or n equal to 1. So if this is the scenario, what is your factorial? Your factorial is 1. So you will simply return 1. Okay, this is your base case. Now let's go towards the recursive case. So what do I mean by recursive case? Recursive case. So recursive case means that now for any number, what is the factorial? So if is that, now I'll write down the else statement. The else statement will say that return what I'm asking you to return. I'm asking you to return, you take that number n, okay, and you multiply it by the factorial of n minus 1. What did we see? That we saw that factorial of any number can be written as n into factorial of n minus 1, right? Just like we saw 7 factorial is equal to 7 factorial is equal to 7 into 6 factorial, right? 7 into 6 factorial. So that is what we are going to write down here. We'll write down n into n minus 1. So now so I will call this function directly here. So this is a function, right? Inside it, I'm calling that function itself. And this is the definition which you read here, that recursive functions are helpful in recursion is a programming technique where a function calls itself in order to solve a problem. So what are we doing to solve this problem? Instead of calculating individually, we are calling this function, it's inside itself only, factorial, okay? And then what will I say? I have to calculate the factorial of n minus 1, because n minus 1, okay? This is the code. So that's all. This is the code to create factorial using recursion. Now, if I call, let's say, factorial of 5, I should get 120, and I'm getting 120. But let us understand what is happening. Okay. So for example, let us say I pass the value of n equal to 5 here. So what will be happening when n is equal to 5? Okay. This function will get called. So you will be calling factorial of 5. Okay, Once you call factorial of 5, what will happen? It will say that, okay, factorial of 5 is equal to 5 into factorial of 4. It will say, okay, to calculate the factorial of 5, just do one thing, give me the factorial of 4. It will say, okay, let me give you a factorial of 4. So what it will do, it will go and call the factorial of 4 here. Okay, now what is the factorial of 4? It will say, okay, now this function will say, okay, if you want to calculate the factorial of 4, do one thing, give me 4 into factorial of 3, which this will be equal to 4 into factorial of 3. Okay, now it will say, okay, now let's go back again. Tell me the value of factorial 3. It will say, okay, now let's do one thing. Give me 3 multiplied by factorial 2. So it will say, okay, factorial 3 is equal to 3. So factorial 3 is equal to 3 into factorial of 2. Oh, it will say, okay, now tell me the factorial of 2. What will be factorial of 2? Factorial of 2 will be equal to 2 into factorial of 1. Now it will say that, okay, tell me factorial of 1. What is the factorial of 1? Factorial of 1 is this, because we have stored here that if n is equal to 1, return me 1. So now this will start back propagating. So what does it mean by back propagating? Now I will start filling the value. What is the value of factorial 1? Factorial 1 is 1. So instead of this, it will replace by 1. So your factorial 2 becomes 2, right? Now factorial 2 becomes 2. So now it will get replaced in this particular syntax. You have factorial 2. So it will get replaced by 2. So this becomes factorial 3 becomes 6. Okay. Now factorial 3 becomes 6. So you will calculate factorial 4 as well. Now what is factorial 3? It is 6. So you will say, okay, factorial 4 is 4 into 6 now, which is equal to 24. Okay. Now what is factorial 5? Factorial 5 is factorial 5 into factorial 4, which is 24, which is equal to 120. And if you see, this is the step of recursion, that you are first of all going from n to 1 and then you are back propagating, right? So what are you doing? Let me explain once again, that you have to calculate the factorial of particular element. Let us say 5, which you do not know. Let me just, what is happening? Yes. So I'm saying give me the factorial of 5. It says, okay, factorial of 5 is equal to 5 into factorial of 4. It will say, okay, I do not know the factorial of 4. So I'll call the function again. Function will say, okay, factorial of 4 is equal to 4 into 3 factorial. Now factorial 3 will say, okay, factorial of 3 is 3 into 2 factorial. And 2 factorial will say, okay, 2 factorial is equal to 2 into 1 factorial. Now, as I mentioned, you need a base case. Now you know this value. Because you know this value, now factorial 2 will become equal to 2. So this will be replaced by 2. So this will become equal to 6. Now 3 factorial becomes 6, which is equal to 24. And then 24 into 5, which is equal to 120. So first of all, you come from here to here. Okay. So you first of all create the problem from n to n minus 1, n minus 2 up to 1. And then you back propagate by filling the values from 1, 2, 3 up to n. And this is how recursion is done, right? So calling a function inside a function. So I hope this is clear. We create a factorial and we define a base case, and then we define the recursive case, and then we have this particular, we'll be calling the function itself inside this, and any programming language allow this. The problem is that why people get stuck is that they really don't understand why do we do this. I hope it is clear now with the diagrams that I explained. So this was the first question, that how to calculate factorial using recursion. So let us read the description once again. Recursion is a programming technique where a function calls itself in order to solve a problem. Recursive functions are helpful in situations where a problem can be broken down into smaller, right? So this was a smaller and identical subproblem, because factorial could be interpreted in its own format as well, right? So one is the base case, which the condition that stops the recursion. Without a base case, you will keep on calling itself infinitely, right? So that is the problem. So without a base case, you don't have a recursion. Next, recursive case, which I mentioned, and call stack. Basically, you are calling each number. So the first problem that we saw was factorial of a number. Let us move forward towards the next problem, that is creating a Fibonacci sequence. So Fibonacci is a very interesting sequence of numbers. What happens in Fibonacci is that every number is a sum of previous two numbers. So what do I mean by this? That in Fibonacci, you start with, for example, with let's say Fibonacci of 0. You'll start with 0, okay, and Fibonacci of 1 will be equal to 1. This is given to you by default, that first two elements will be given to you, and you will be asked to generate the remaining numbers. So for example, they will ask you, tell me what is Fibonacci of 10. Okay, how will you create that? So what does it mean? That what you do in Fibonacci 2, it becomes equal to Fibonacci of 1 plus Fibonacci of 0. So what is Fibonacci of 1? It is 1. So this is equal to 1 plus 0, which is equal to 1. So you got Fibonacci of 2 equal to 1. Now suppose you calculate Fibonacci of 3, which is equal to Fibonacci of 2 plus Fibonacci of 1. Now what is Fibonacci of 2? It is 1, and of 1 is 1. So it is 1 plus 1, which is equal to 2. Now if you have to calculate Fibonacci of, let's say, 4, what will you do? It will be Fibonacci of 3 plus Fibonacci of 2. So it will become equal to 2 plus 1 equal to 3. Okay, that's how you will keep on generating the numbers. So let us try to generate few of the Fibonacci numbers before, like, rather than simply. So first is 0, second is 1, third will be 1, then fourth will be 2, then fifth will be 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21, 21 plus 13, 34, 34 plus 21, that is 55, and then it will be 89, sorry. So that's how you will go, right? And this is the, like, so you can calculate the nth Fibonacci number. So suppose if someone asks you, they give you a code that generate me this Fibonacci sequence, or tell me any Fibonacci, let's say tell me Fibonacci of 200. How will you do that? So let's try to break down this using first of all architecturally, then we will go towards the coding. So whenever someone asks you in Fibonacci, what is the happen, that Fibonacci of any n element is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is the formula for Fibonacci, and this is, you don't need to like remember this. Like, this is what we have been doing, right? We take the previous sum, previous element, and we take the previous the number prior to that. Okay, so for example, let us say Fibonacci of, so suppose you have to calculate Fibonacci of 5. What will you do? Fibonacci of 5, and what do we know? We know that Fibonacci of 0 is equal to 0, and we know that Fibonacci of 1 is equal to 1. Because if this is not given, you cannot solve it, right? So let's calculate Fibonacci of 5, or let's say calculate Fibonacci of 6, okay, for this example. So Fibonacci of 6 will be equal to Fibonacci of 5 plus Fibonacci of 4, okay? Now we do not know Fibonacci of 5 as well, 4 as well. So what will we do? We will say, okay, let's do one thing. Fibonacci of 5 will be Fibonacci of, so it will be Fibonacci of 4 plus Fibonacci of 3, okay? And what will be Fibonacci of 4 here? From this, it will be Fibonacci of 3 plus Fibonacci of 2. So, okay, now what you will do, see, it becomes technically equal to Fibonacci of 4 plus 2 times Fibonacci of 3 plus Fibonacci of 2. Okay, now we will further break them. So what will happen? It will be Fibonacci of, so you'll break 4, it will be Fibonacci of 3 plus Fibonacci of 2. Okay, then it will be Fibonacci 2 times Fibonacci of 3 plus Fibonacci of 2, correct? And now what will happen? It will be equal to 3 times f3, and it will be, so f3, it will be 2 times f2. Okay, now you will further split Fibonacci of 3 as well. So what it will be, 3 times Fibonacci of 2 plus 3 times Fibonacci of 1. And what will be 2 times Fibonacci of 1 plus 2 times Fibonacci of 0. Okay, now let's go a little bit down. So it will be equal to I'll say 3 times Fibonacci of 1 plus 3 times Fibonacci of 0 plus 3 times of Fibonacci of 1 plus 2 times Fibonacci of 1 plus 2 times Fibonacci of 0. Now let's club everything together. So 3f1, 6f1 and plus 2. So it becomes 8 times Fibonacci of f1 plus, okay, so this is gone. Now we remain this and this. So what is it? 3 plus 2, it is 5 times Fibonacci of 0. Okay, so I think that is it. So what is the Fibonacci of 1? Fibonacci of 1 was 1 and of 0 is 0. So if we just do, it will become equal to 8 times to 1 plus 5 times 0, which the Fibonacci of 6 will come out to be 8. Okay, let us try to generate it. So let us generate the Fibonacci directly. So Fibonacci of 0 is 0, of 1 is 1, of 2 will be equal to 1, of 3 will be 2, of 4 will be 3, of 5 it will be 5, and the Fibonacci of 6 will be equal to 8, right? So this is Fibonacci of 0, 1, 2, 3, 4, 5, 6, and that is how it is generated. So what do we see that? We see that every Fibonacci can be split into n-1 plus n-2 given the base condition that f of 0 is equal to 1 and f of 1 is equal to 1. So this is what we are going to code now. So let us write down the code now. We will write down def Fibonacci, okay, and we will say n. Okay, give me any number, I will give you the Fibonacci number of that. First of all, what do we have to write? We have to write down the base case. So what do we know? That if n is equal to 0, the Fibonacci will be 0, and if n is equal to 1, Fibonacci will be 1. So let us write down, it says that if n equal to 0, right? If n is 0, what is my number? I will return as 0. Okay. Now, if I'll say elif n equal to 1, what is the value if n is equal to 1? I will say return 1. Okay. And else, what do I have to do? Now I have to write down the recursive case. So write down the recursive case. The recursive case says that I have to return. Okay. Now remember, Fibonacci of any number is what? It is n-1 plus n-2. So you will simply call the function Fibonacci itself. You will say Fibonacci n-1 plus Fibonacci of n-2. Okay, so you will call this here and you will call this here. That's it. You have written down the function to create Fibonacci. See, it is very simple because you are looping around here and there, right? Suppose someone calls the Fibonacci of 4. So what will be it? Let's say someone calls Fibonacci of 4 or 5, example. Fibonacci of 5, you will say, okay, Fibonacci of 5 is equal to Fibonacci of, as we just saw, it is equal to 4 plus Fibonacci of 3, right? And then you will say, okay, f of 4 will be equal to f of 3 plus f of 2. Okay, and f of 3 you will say will be equal to f of 2 plus f of 1, correct? And what will be f of 2? F of 2 will be equal to f of 1 plus f of 0, right? Now we have this case. Now remember, we know that f of 0 is 0 and f of 1 is 1. So 0 plus 1, f of 2 will become 1. Okay, so I know f of 2 is 1 and f of 1, I know f of 1 is 1. So 1 plus 1, it becomes equal to 2. Now I will put in this code, if you see, I have f of 2, I have f of 3. So f of 2 will be placed as 1 and f of 3 will be placed as 2. So this is 2 plus 1, which is equal to 3. Now f of 5 is f of 4 plus f of 3. What is f of 3? F of 3 is 2 and f of 4 is 3. So 3 plus 2, it becomes equal to 5. So that's how you generate. You first of all came down, then you backtrack, right? So this backtracking is available in Fibonacci. So technically, in recursion, what do? We define a base case and we do a recursive case and we call the function inside a function. We call the same function inside a function and it will go on looping. Okay, so let's go towards one last question, which is about calculating sum of a digit. So let us understand sum of digit using recursion. We have done sum of digit when we were doing for loop and while loop. Now we will try to understand how to sum a digit basically using recursion, because it's very important, it's very interesting. So suppose we have this number 1, 2, 3, 4 and we want to sum its digit. So what do I mean is that it is 4 plus 3, 7 plus 2, 9 plus 1, 10 is the sum. So technically, how do we get it? If you remember the previous class is how do we calculate the sum? Suppose you have 1, 2, 3, 4. What do? You take the remainder and you store. You divide the number by 10. So what you do, actually, you have a current number. You'll create a quotient and you'll create a remainder. So what do? That, okay, first of all, you will divide 1, 2, 3, 4 by 10. Okay. You will place the remainder here. So for example, 1, 2, 3, 4 divided by 10. What is the remainder? It is 4. And what is the quotient left? It is 1, 2, 3. Okay. So now what you will do, you will start summing up. So after this, you will create a sum value here. Okay. Sum is equal to what is the current remainder, that is sum, and you will keep on adding. So for example, now you will divide by the remainder quotient by 10. So the quotient left will be 12. The new remainder will be 3 and you will get 4 plus 3, which is equal to 7. Okay. Now again you will divide by 10. You will get as quotient as 1, remainder as 2, and it will be 7 plus 2, which is equal to 9. And then last you will divide by 10. So you will get quotient as 0, remainder as 1, and it will be 9 plus 1, which is equal to 10. So that is how we take sum of any digit. We keep on dividing by 10 and we reduce, we create and we take a quotient, right? Every time we divide by 10, we take a quotient and we keep on adding the remainder, right? That's what we do in a recursion. That's what we do while summing a digit. Now we have to convert this using a recursion. Okay. So what will you do? Let's try to deep dive on this. So okay, suppose you are given a big number 1, 2, 3, 4, 5, 6. Okay, can you say that, okay, the sum of 1, 2, 3, 4, 5, 6, sum of 1, 2, 3, 4, 5, 6 is equal to the unit digit, that is 6, plus sum of the digits of 1, 2, 3, 4, 5, correct? 1, 2, 3, 4, 5. Okay, now I will say, okay, now tell me what is the sum of 1, 2, 3, 4, what is the sum of 1, 2, 3, 4, 5? You will say, okay, the sum of 1, 2, 3, 4, 5 will be 5, that is the unit digit, plus sum of the digits of 1, 2, 3, 4. Okay, then you will say, okay, now tell me the sum of 1, 2, 3, 4. It will say, okay, let's do one thing. It is equal to 4 plus sum of digits of 1, 2, 3. Correct? Now again it will repeat. It will say, okay, sum of 1. What is sum of 1, 2, 3? It is 3 plus sum of 1, 2. Correct? Now what is sum of 1, 2? Sum of 1, 2 is equal to 2 plus sum of digit 1. Now when you have only one digit left, that is 1, what is the sum of it? Its value is technically 1 only. So what it will become, so this is 1. Now this is my base case, right? That sum of 1 or any digit or any single unit digit, right? For example, 1, 2, 3, 4, whatever it is the number itself. So it is 2 plus 1, which is equal to 3. So what do I get from this? I get sum of 12 equal to 3. So I will back propagate it here. Now it will say sum of 1 to 3 is 3 plus 3, which is equal to 6. Correct? Now I got sum of 1 to 3. Now I will back propagate it. 6. It will give me 10. Now I'll back propagate it. It will give me 15. Now I'll back propagate it. It will give me 21. So this is how we have created a tree starting from the top and we are going till the bottom. So this is how recursion is applied logically here. Now let us go towards the code and try to understand it. So in the code, let's define the function def sum of digits. Okay, sum of digits, and we are taking a number n. Okay, what is our base case? Our base case is that whenever number is 0, right, we will return it as 0, because see, the sum of any digit is 0 itself, right? So I'll say if n is equal to 0, okay, then what is the case? Return I will say 0, or I can say that if n is less than equal to 9, okay, I will say that return n. Correct? Is that true? That till you are reaching, till your number is like this only, you are returning that number only. So this is your base case. Now after the base case, what do you have to do? You have to write down the recursive case. So we will write down the recursive case. Recursive case says that recursive case. Now recursive case comes here. We will say that just let me check if indentation is proper. Yes. Now recursive will say that else. What do I have to do? Return. Now here is the important part. So if a number comes, what will I do? I will take the unit digit. What is the unit digit of a number? The remainder that I get after dividing by 10. So I will say n remainder 10. So this will give me the unit digit that I need. Plus, what will I call? I will call the sum of function itself. I'll say, okay, do one thing, call yourself only sum of digits. But what will it do? Now comes the important part. We do not call n. We do not call n minus 1. What is happening here? That every time number is getting divided by 10, right? So 1, 2, 3, 4, 5, 6. Let's say this was the number. You divide by 10 and you get the quotient. This is your next number. So what will we do? We will take n, divide by quotient, and we will get the 10. And this is your result. Okay. So let me just run it. Now let's check sum of digits. And let's give a very big number, 1, 2, 3, 4, 5, 6. For example, the sum was coming to be how much here? 21. Let's see. It should come as 21. Okay. Suppose I give the value as 1 only. So it will give me 1. Let's say I give 1, 2, 3, 4, 5. It will give me 15. And let's say I give some very big number. It will give me that number. So that's how you are going to get it. Now let us understand. For example, if I'm calling sum of digits. If I'm calling sum of digits 1, 2, 3, 4, 5, how is it working? Let's try to see that again. So it will say this is equal to 5 plus sum of digits up to 1, 2, 3, 4. Correct? Now what is sum of digits of 1, 2, 3, 4? To call that, it will say, okay, this is equal to 4 plus sum of digits of 1, 2, 3. Okay, now it will say, okay, what is sum of digits of 1, 2, 3? This is equal to 3 plus sum of digits of 1, 2. Correct? Now I'll say, okay, what is sum of digits of 1, 2? It will say that this is equal to 2 plus sum of digits of your unit digit of a single number. Now what is this? We have mentioned if it is less than equal to 9, it means that it is greater. It is basically that only. So this is 1. So this will become equal to 3. Now if this is 3, I'll replace this by 3. So what is 3 plus 3? It becomes 6. Now it becomes 6. So if you push it here, it will become 10. Now 10, if you put it here, it will become 15, right? So ideally sum of digits of 1, 2, 3, 4, 5, it should be 15. Let's cross check it. What is the sum of 1, 2, 3, 4, 5? It is 15 only, right? So first we come down the tree, then we back propagate it. And this is what the recursion is. So I have explained you using 3 examples. First we did factorial, right? Then, so first of all, what we did factorial. then we did Fibonacci sequence, and then we did the sum of digits. So this was recursion, and I hope it is clear. First of all, remember the key to understand regression is, first of all, you have to create this pattern, because if you directly jump in the code, right, you will never be able to solve, because this is something, it takes some time to understand conceptually. Okay, what is the pattern, how should I return, what should the code is very small. If you see, the code is very small. We are doing so many big things in small part only, but the main thing is that, like, we are able to solve very complex problems very efficiently. It like reduces your time complexity. It's a very efficient way of coding recursion. Like, if an interviewer sees that you know recursion, you will get bonus points for sure. I can give it written. Like, I am sharing my personal experience. Whenever I have given interview, every time person asked me, can you solve this problem using recursion as well, right? I have faced this almost every time. So always keep this in mind. Try to solve using recursion. It's a very interesting concept. So you have 7 questions after this in assignment. Power of a number, product of array elements, reverse a string, everything can be drilled down to a pattern. So do that. You will get a week and submit this assignment as soon as possible. I hope this explanation of recursion was clear to you. If still you have any doubt, you can reach out to me and you can comment below the video, or like you can email me, WhatsApp me, or you can comment below the video. So thanks for watching the video. I'll come up with another algorithm very soon, and till then, practice it, practice more problems on it. If you need more problems on recursion, you can let me know. I'll provide a special assignment as well on recursion, but keep on practicing. Recursion will come with practice only, because it is not very intuitive. Like, a lot of you are not programmers from a long, right? So you should train yourself in coding this way. So a lot of problems can be solved using recursion, and it is a very efficient technique. So thanks again. I'll see you in the next video.